Today we are going to look at relations, domains, and ranges of different sets of ordered pairs. And that's what a relation is. It's just a set of ordered pairs. However, it can be conveyed a number of different ways. So let's take a look at a set of ordered pairs. And typically when they write a relation, they're going to use a brace to symbolize that they're talking about these points are all together. So I'm going to use this relation here, 0, 2. We'll do 3, 2. And we'll do negative 3, 2. So that's my relation, just these 3 points. So there is different ways to relate this relation. We can use the ordered pairs, as we have done here. We can make a table. And so a table would just have our input and output values. And typically when we talk about input values, we use the letter x, or the variable x. And when we talk about outputs, we're typically talking about y. But they don't need to. They could use different ones like C and D, or E and F, or any ones they wanted to. But typically we have x for inputs, outputs, or y. So we think of the first number here as our x value. The second number is our y value. So we always have input first, then the output. So in this case, 0, 2. The next one would be 3, 2. And negative 3 and 2. So that's the table form. We could also use what they call a mapping diagram. And so for mapping, what they do is they just list the inputs. So we've got our 0, our 3, and our negative 3. So those are our different inputs. And what we do from there is we talk about the output on this other side. So we only have one output here. They're all the same. So what they do is they just draw an arrow from an input to what the output is. In this case, since they're all the same, we just draw arrows to that too. So that's the mapping diagram. The graph. Well, the graph is just on a coordinate plane. So you have to sketch a coordinate plane first. So we've got our x-axis, our y-axis, and then we just plot the points. So 0, 2, so going up 2 spaces. And then we have 3, 2, so over 3 spaces to the right, up 2. And we have 2, 2, or negative 3, 2. So over 3 to the left and 2 up. Now don't draw a line between those points, because if you do, that line would represent other ordered pairs. Each point that makes up that line would represent an ordered pair. And there are not any others than these 3. So just points, just dots on that graph is all you need. So those are the different ways to convey the relation. Now let's take a look at some vocabulary within the relation. We talked about x values, inputs, and y values, outputs. Well, there's another term they use for x values, or inputs. And that's the first set, or the first coordinate of the ordered pair, and it's called the domain. So if we take a look at an example here, if I just go ahead and sketch a relation, and I can sketch the relation in any of these 4 ways. I'm just going to do it in the ordered pair format here. So 0, 5 is one of the points. Let's go with a negative 2, 8. And how about a 0, 2? So this is my relation. And so what they're asking for is the domain. So if you were to find the domain, you just write the word domain, put a colon, and then just list the numbers. So the domain is, or the domain values are, 0 and negative 2. That's it. We don't have to rewrite the 0 twice. We can just write it once. If you do, it's not a big deal. It doesn't mean it's wrong. Those are just values. So those are the domains. They'll also ask you about range values. Range values is another way to represent the y component, or the second coordinate in the ordered pair. So let's go ahead and use a different kind of format. Let's use how about a mapping diagram. So let's say we had 3, 5, and 9. Those are our inputs, and then we had 2 and negative 8. And let's say we had something that looked like this. So we have our inputs here, and then we have our outputs, corresponding outputs. So they're asking for the range values. So the range is just the y components. So here it's 2 and negative 8. That's it. That's all you're going to do. You're just stating what those are. Well, it gets a little bit more difficult when they have lots of points, when they have a curve or a line. So let's take a look at an example here. Sketch a coordinate plane again. Here's our x-axis and our y-axis, remembering that the x-axis represents the domain and the y-axis represents the range. And so what we're going to do is I'm going to go ahead and draw a line, and to be really specific about this, I'm going to start here at 2, and let's say I go over 4 spaces to the right and up about 4 spaces. So that point is at 4, 4, and it's a closed circle. Then I draw a line between those points. Alright, so now we've got more points than we can count. Even though it seems like a short line, every single point, all the intervals, even between, the numbers between these intervals are points. So there's so many you can't even count them. So what we have to do is use an inequality to represent them. So if I wanted to represent the domain runs along the x-axis. So let's take a look at that. So the domain runs from this point here, so from here at 0 all the way to 4. So this is our domain. The domain are all these numbers in here represent the first component or the first coordinate of each ordered pair that represents that line. So the way I'd write the domain would be that the values of d, I'll use d right there, are going to be greater than, or equal to 0. Greater than or equal to, because 0 is one of the points, but they are all greater than 0 as well, like 1, 2, 3, and 4. Those are all bigger than 0, but they stop at 4. So to show that, you're going to say d is less than or equal to, see how it points towards d, less than or equal to 4. So this is a conjunction. It's an and statement because it's all values within a certain points between 0 and 4. So those are the domain values. Let's take a look at the range values. So the range values go from this point here to this point here. They're all the numbers in between those 2 points. So if I was to say what the range was, I would say the smallest point is 2. The highest point is 4. So 2 and 4 are the the values in between. So again, we're not dealing with domain here, we're dealing with range. So the range values are greater than or equal to 2, but less than or equal to 4. And those are the different range values. So that's the most complicated one. So let's take a look at one more example similar to that. So let's say I'll draw a curve this time. So we've got our coordinate plane, our x-axis, our y-axis, and this time I'll start, let's go up 1, 2, 3, 4, 5 spaces up. And then let's say I go over 1, 2, 3, just 3 spaces, and then I'll put a dot 5 spaces up. And so let's say it curves down, it comes down, and then it just touches this point right here, and then it curves back up. But it doesn't go past this point. So this is the end point, and this is an end point. So that's what our graph looks like. Alright, so what they want to know is what's the domain, what's the range. Alright, so let's go ahead and look at just the domain. So the domain is along the x-axis. So this is our domain. So what we're going to do is see what the smallest domain value is. Well, the smallest domain value is at 0. The points that make up this curve, the smallest one is this point right here at 0 for the domain value. The highest point is this one right here. So they run in between those values. So the domain values are between 0 and 3 because it goes 1, 2, 3. So between 0 there and 3. So to show that, put the d in there, and since it equals, because it has that solid circle, the values of d are going to be less than or equal to 3, but greater than or equal to 0. So those are the domains. Let's take a quick look at those range values. Ranges, again, run from 0 up to 1, 2, 3, 4, 5, they run up to 5. So there's 5, here's 0. So the range values go from 0 to 5. So to show that, put the r in the center, so range is represented by r. Range values are less than or equal to 5, but greater than or equal to 0. And those are the different range values. Well, those are the problems on tonight's homework. You also have some equations to solve, which is on page 88. You can go back into past lessons if you're unsure how to do that. For instance, day 12 and day 11 have some lessons on those sections, so check out those if you're unsure about how to do those problems. Well, good luck on tonight's homework.